But there are thermostats out, but now I'm gonna tell you, there are thermostats out there that if it has the E or AUX the AUX and E terminal, if you flip it to emergency heat, it's only gonna go out on that terminal.
I know some Honeywell products will have their zone boards, and depending on the way the programming is and with the input wiring, the output wirings could be different.
Right.
So I know that some dealers like to make it a habit where they say, if you see any W signal or any E signal or aux signal,
Right.
you automatically daisy them all together to
Right.
ensure that
And
when
you
I want
can,
to run.
realistically, you can daisy together, it doesn't matter. Just be warned that if you daisy those three together,
Oh, she's all gonna run.
well, yeah, and not to mention the fact you're probably gonna see 12 in it every time the auxiliary heat comes on. Okay, so now we're gonna talk about operation. Okay, so here's your electric heat strip kits. Again, 3, 5, 8, 10. These are what's available. I'm gonna tell you that they say that that you can use that 5K on 3 count. I wouldn't do it. You get more heat out of a toaster.
Too much air.
So just be careful when you're sizing your electric heat. That 24K right there is capable of using a 15 kW heater. You can get enough airflow out of it for 15 kW.
You could dry your clothes on them over a register with the heat.
Just about, yeah. So size your heaters correctly. Chart at the bottom, or the table at the bottom, shows the difference in your airflows when you change the dip switches S4 1 through 3, SW4 1 through 3. So let's just take this 3-ton heater. When it's all off, it's 1306. It's 1306 CFM. If you turn number 3 on, it drops it to 1241. If you turn number 2 on and leave 1 and 3 off, it drops it to 1176. And if you turn 2 and 3 on and leave number 1 off, it drops it to 1112 CFM. That's how you can adjust your air. That's how you can adjust your airflow. That's how you can adjust your airflow to possibly get more heat out of that electric heater if you need it. At the bottom, I want everybody to pay attention to that red line across the bottom. It says when auxiliary heat is energized, the AHU will automatically be running with the turbo fan speed. Electric heater in the 454. All right, so how many people, show of hands, how many people in here have heard of the Daikin patent that they just put out back about a year ago? That refers to electric heat and fan operation. Really, none of y'all heard that? Okay. So Daikin, in the beginning, when they were doing, when 454B equipment was starting to be developed, and we were starting to talk about going to A2Ls. It's not just 454B, it's A2Ls, period. Daikin was working with the DOE and the other regulatory bodies to come up with the rules for these, because remember, Daikin, in the beginning, owned the rights to R32. So they were working with these government entities. And this was some good lawyering here, I'll tell you, because I don't know how it got passed, but Daikin actually was able to patent an operational procedure that every manufacturer has used for the last 50 plus years. And that is when the auxiliary heat comes on, the fan continues to run and doesn't stop. Every one of them, when the auxiliary heat, when you've got the heat pump running and it calls for the auxiliary heat, the fan continues to run, they energize the auxiliary heat, and that's the end of it. Daikin patented that.
What?
For 454, for the A2Ls. They patented that operation for A2L. I don't know how they did it. I don't even know how you can actually patent an operation like that. Not specific to 410A, but specific to A2Ls. So, most of the other manufacturers out there said, screw Daikin, we're gonna do it our way anyway. China being a Chinese, or Midea being a Chinese-owned company, our legal team in China, and we tried to find a way around this patent. Don't think we didn't. We spent 6 months trying to find a way around this patent. But the China legal team, because we couldn't find a condition where we could get around the patent, the China legal team doesn't want to stir the water or muddy the water with President Trump being in office because they're a Chinese-owned company. So this is what they came up with. So when the system is running and the heat pump is running, when the auxiliary heat calls, notice here, start of auxiliary heat, your fan's running, okay? When the auxiliary heat call comes in, the system shuts down. Shuts down for 30 seconds. After 30 seconds, the blower starts. I don't know what difference this makes, but after 30 seconds, the blower starts, runs for 10 seconds. 10 seconds after the blower starts, the electric heat's energized and the system restarts. I've actually seen that operation in our lab.
So you're saying that if, and this is in 24-volt mode and communicating mode?
And communicating mode.
So you're telling me that someone can stand in front of one of these air handlers, run heat pump, everything will be running and everything will be doing exactly like it's supposed to, but the moment that it engages strip heat, they will notice the blower will shut down.
Yes,
And
they will
then
notice it
turn-
shut down. 30 seconds later, the fan will restart, and then 10 seconds after that, the electric heat comes on.
Just the blower motor
Yeah, just the blower for that 10 seconds.
shuts down for the 10 seconds.
Even if it's.
No, no, it doesn't shut down. It shuts down for 30 seconds.
30.
So even if the heat pump's running? with the
Yeah, it'll
W
shut this off.
Okay, so both pieces are shut.
Both pieces will shut off. The both pieces will shut off. They'll shut down for 30 seconds. Remember, this has a 3 minute, now, this has a 3 minute recycle delay. So if it shuts off, it's gonna start back, and this process, at the end of this process, once the auxiliary heat comes on, 3 minutes later, the heat pump comes back on with it. That's the way it works.
Thanks, Dakin.
Huh?
Thanks, Dakin.
Yeah. So my educated guess is gonna tell you that once the patent expires, everything will go back to normal. And somebody is gonna keep Daikin from redoing that patent. Here's the other thing you gotta remember too. Me and Aaron were talking about this last night. A lot of this stems from Daikin. Remember, Daikin's a Japanese-owned company, not a Chinese-owned company. Daikin has good, or Japan has good relations with President Trump. China does not. So our legal team in China did not want to muddy the waters. They didn't want to make things worse for us as far as tariffs and imports. So this is what they came up with. Now, some of your customers may never notice this, but some of them might. I wanted to show you all this so you all can be aware that this is how the system is going to operate for right now, and that this is normal operation. And you can tell the customer, y'all can tell your customers whatever made up lie you want about why it does it.
You know, although Daikin.
That's beyond me.
Daikin owns the
Well-
patent of R32, R454B has R32 and R1234 white.
But then
Right.
most of these systems aren't gonna be calling for strip heat.
You're not, so you may not, like I said, you may have customers that may never notice it.
Not that big.
It all depends on how much auxiliary heat, on how many times the auxiliary heat cycles.
Yeah.
So what I would do is, I like I said, I want you all to be aware of it, but don't make a big deal out of it with the customers unless they ask for it, or unless they ask about it, or they happen to notice it. because I'm gonna tell you I wouldn't. Sensors. Let's talk sensors here. All of these sensors are used for control, compressor, compressor control, fan control, and your capacity control. So T1 is your indoor temperature sensor. That's the T1 that's that's right there underneath that coil.
On the return,
Yeah, that's your return air sensor. Or they say indoor room, but it's return air.
yeah, so it's
Okay.
measuring the indoor air temp through the return.
If you're using the wired wall control, T1 comes from the wired wall control. T2, T2A, T2B are all indoor coil or evaporator coil temperatures. T2 is the inlet temperature. T2A is the middle of the coil, and T2B is the outlet temperature. Those three are averaged for control. T3 is the outdoor coil temperature. It is buried in the bottom, about right here on the coil. Like all the way down here. T4 is the outdoor ambient temperature. T5, TD are what you'll most commonly see it referred to as TP, is the compressor discharge temperature. There are protections built in for T5, or let's see, T3. Actually, there are protections built in for T2, T3, T4, and TP. And then, of course, TS is your temperature set point. All right, so the GA algorithm, this is what the system uses for control. The way our algorithm works, we get more stable room comfort. And you'll see that here in a few minutes when I show you what it actually does. We have the ability to do flash heating and cooling. Remember, we have turbo mode on this. So if you put this turbo mode, it ramps everything up. And then you get lower operating costs. So typical on-off thermostat, on-off machines, conventional two-stage or single-stage compressor. Your controls like this. You have these wild temperature swings because most of the time your thermostat has to go at least 1 or 2 degrees above or below before it cycles on. So you had these wild, not really wild, but you had these big temperature swings with on-off control. A lot of the inverters out there, or a lot of the variable capacity equipment out there, starts down here, starts at a low speed, ramps up, levels off, and then runs that way for a while until it satisfies the thermostat and then shuts off. Ours I'm gonna go forward and then back. All right. So ours starts up here. Ours starts at a maximum calculated frequency. That frequency is calculated by the difference between T1 and TS and the temperature condition of T4. So depending on what those conditions are, it's going to start at a maximum calculated frequency. Most of the time what we see is it start at about 70%, somewhere in that range, which is about 45 to 50 hertz. So it will start there, it'll run for the first 5 minutes that way with no modifiers, no adjustments, no anything. The only thing that will shut the system down is one of the pressure switches or the T5 the TP temperature limit, the temperature discharge limit, pressure discharge limit. That's the only thing that will shut it down during that first 5 minutes. After 5 minutes, it starts to recalculate. and it looks at compressor frequency. If the frequency is equal to or greater than 40 hertz, it will recalculate every 90 seconds, looking to adjust its speed. Remember, we want to run up here, but we also want to get down here. Our idea is we want to start up here, give you that quick blast of heating and cooling. And then we want to get into this maintenance mode where we drop down, we keep dropping down, and we get to the point where we're right around set point and we hover there. Idle. And we run for a very long time. One of the things you might hear from some of your customers at the beginning is this thing comes on at 8 o'clock in the morning and it doesn't shut off till 8 o'clock at night. That's what it's supposed to do. This is how we can give the customer more stable room comfort by these long run cycles. If you oversize the equipment, you're not going to get those long run cycles, and you're going to have an unhappy customer because they're going to see the same temperature swings that they had with their old system. If the frequency is between 20 and 40, it reevaluates every 2 minutes, and if the frequency is less than 20, it reevaluates every 150 seconds. Remember, as the temperature, as the frequency, so just remember, as the frequency goes lower, the reevaluation period gets longer. Now, let's go back.
How low will the frequency drop?
All right, so standard, it used to be 12 hertz. I think I've seen as low as 8 hertz. But once it hits the minimum frequency, once it goes below the minimum frequency, the system will shut off anyway. So this table will not help you all. This table, I'd already cleaned this up. I know I did, and I probably hid the wrong slide because I got the, or I did something with it. So just ignore the gibberish on the left. That's engineering speak for, we don't know how to explain it to you. Or we don't want you to be able to explain it to somebody. What I'm going to tell you, this table, I'll put this table up here so that you all can have an idea of what happens at each reevaluation period. So when it looks at the reevaluation, during its reevaluation period, it's looking at the difference, it's looking at the temperature difference between T1 and TS. And then it's looking at the temperature trend in the room. Temperature trend of T1. So what I'm going to tell you about the table is a slower trend will force the system to add or subtract more capacity. And a faster trend will slow it down. So it will add less capacity with a faster trend and more capacity with a slower trend. So if you get that room up here and you've got a temperature difference of, let's just say it's 3.5. Okay. If the temperature trend is trending really slow, it's going to add more capacity. If that temperature is dropping quick, it'll add less or start subtracting capacity. It's all going to depend on how fast that temperature in the room is trending. But this right here, I showed you all this so you all have an understanding of how it actually operates, but it won't help you in the field diagnose anything. All right, so to shut off, it has to meet one of 3 conditions. Either the calculated frequency has to be less than F-min, which is 12, well, I'm going to tell you 12 hertz. If it gets less than 12 hertz, the system's going to shut off. That's your minimum frequency. Whatever it may be, whether it's 8 or 10. I know they were going to change it. I've only seen it once on one particular unit, so I can't tell you that they've changed it across the board. Number 2 is if the compressor runs at the minimum frequency for more than 10 minutes. So if it's sitting here idling along and it's at 12 hertz and it runs that way for 10 minutes or longer, it's going to shut off. The reason that is is because if it runs to 10 minutes for minimum frequency, we know that we're at the room temperature, we're at the set point. The third condition is if T1 becomes greater than or equal to TS minus 1 degree Fahrenheit. So if the temperature in the room, so if it's cooling mode, which is what this shows, if the cooling in the room, if the room temperature becomes more than 1 or 1 degree, well, yeah, more than a degree or more, less than what the set point is, then it will shut off. So if your room's set for, if you got it set, if it's set for 70 or it's looking at 70 degrees for a set point, once the room temperature reaches 69, it shuts off. It's the opposite of heating. Once the room temperature, actually, yeah, it's the opposite of heating. Once the room temperature gets a degree above. So if your set point is 70 and the room temperature hits 71, it shuts off. This is outdoor fan speed control. Low ambient cooling. All of our units come with low ambient cooling capability built into it. They will cool down to minus 20. The high heat model of this will cool down to minus 22 degrees.
It will cool when it's minus 22 degrees outside. Is that fan even running at that point?
Maybe not.
Probably not.
But when you enter, so my point, when you enter low ambient cooling, so the outdoor fan speed is actually controlled by T4, the outdoor air temperature, not the coil temperature. If you enter low ambient cooling, which basically means the air conditioning is running and the temperature outside drops below 59, less than or equal to 59 degrees, the system will enter low ambient cooling. At that point, fan control switches from T4 to T3 because we want to make sure we maintain a certain coil temperature.
Yeah.
That is to keep it from freezing. Yeah. Even though our systems are designed not to freeze.
But we're pulling air from a basement that's already cold just to achieve cooling on a main floor when it's low ambient conditions.
If T2 gets down to 30, so basically the way the GA algorithm works is T2, and you're running a cooling, and T2 and the T2 temperature gets down to 32 degrees, it's going to shut off anyway.
Yeah. It's
going to shut it down and protect itself. Our systems are designed not to freeze the coils. If you've got a coil that's icing up, you've got a refrigeration problem.
Yeah, have to at that point. Because even with airflow, it'll start to ramp itself down.
Right. So, so it will choose the temperature T3 to control the fan speed. When it goes back, when the outdoor temperature, when the outdoor ambient goes back above 59 degrees and the coil temperature becomes greater than or equal to 100 degrees, it will exit low ambient mode, and T4 will now control the outdoor fan speed. Does everybody understand that?
Yes.
All right. This is compressor start frequency control. This slide actually is in the wrong spot, so I've got several things I've got to correct before I resend this to Aaron. Because this should be with that table that shows you the frequency refresh rate. So this is basically the selected fan speed based on what your current calculated frequency is. So 80 to 100% auto turbo and high. There's no limit. If your fan no, this is based on your fan speed. So 60 to 70%, 60 to 79%, which is medium speed. You're at max fan. Low is mid fan. 60 to 39% is minimum fan, and then 1 to 5% is GA 1 fan. This is on your high, medium, low. So this is what you're looking at. So there's no limit on the fan speed here. Your max fan speed, your max cooling fan speed is what you're at here. Your mid fan speed is your limit here. And then in this operation, you're at minimum fan speed. Ignore the 1 to 100% stepless. That's a ductless fan speed control.